Welcome to another exercise for the workbook Statistics. This time I'm going to focus on classified data, or rather on the calculation of measures of central tendency for classified data. So our data set here is the following table regarding grouped age in a sample. So for all the participants in a sample, that's those ones here, we have their answer which age group they want to be part of or checked in the survey. Now, what should we do with this? First off, in part A, we should calculate as well relative and cumulated frequencies for this data set. Based on the results of part A, we should also calculate median age and average age. So simply calculate median and average for this data set. So let's start with the first part. We're going to take the data set as is, and we're going to add the sum of all absolute frequencies, telling us how many observations we actually have here. So in this sample, we have 104 observations. Now we're going to add two additional columns to this table. In the first column, we're going to put the relative frequencies, and in the second column, we're going to put the relative cumulated frequencies. The relative frequencies can easily be calculated by simply dividing the respective absolute frequency by the sum of all absolute frequencies, so by the number of observations. So for the first one, we have 38 by 104, then we have 27 by 104, and so forth. Once we calculated all these relative frequencies, we can check whether we did this correctly by summing them up as well. Because in the end, they need to sum up roughly to 1.0, to 100%, meaning that all observations are covered by one of these 5 groups. Well, that's our first check. And then we can use these results to get our second new column, the relative cumulated frequencies. Here we're going to add up all the relative frequencies up to this point. Meaning here we're in position 1, so we're adding up all relative frequencies up to position 1, which is just the first one. The second one, we're going to add up everything until 2, so the first one and the second one. And to make this a bit more efficient, what we're going to do next, we're not always going to add up all this stuff. You might imagine if this is a table with a lot of different classes or groups, this might become really tedious over time. So to speed this up, we can simply take the relative cumulated frequency from before and add to it the relative frequency of this class. So here we could go 62.5 plus 13.46, giving us here this result. Then those more or less 76% plus the 15%, giving us this one. And finally, we're here as well with 1.0, or more or less 1.0. So it could be that you're slightly off on the last decimal, but it should be 1.0 or 0.999 until the last decimal. All the rest is just rounding errors. If this is not close to 1.0, then you made a mistake, because similar to this is just all the values summed up. Well, that was already part A. So let's continue with the second part. Here we're going to work with the same frequency table. And I'm going to calculate the median, which is simply the value in the middle, which here might sound strange. In the middle means 50% is smaller, 50% is larger. So I have to find this class which actually contains this cutoff value, being smaller, larger than 50%. So I need to find the class, the group, which for the first time reports a cumulated frequency larger than 0.5. I'm going to take a look here. This is smaller than 0.5. This is larger than 0.5. So this here actually is the first group, first age group, with a cumulated frequency larger than 50%. So this age group contains our median. This is the so-called median group or median class. From a median class, we're going to use lower and upper bound of the class, so the 24 and the 30. We're going to use the relative frequency, and we're going to use the relative cumulated frequency of the class before. course, if we take a look at the formula, that's exactly what we're going to need here. The use is lower and upper bound of my group. So this is the lower bound, which here is the 24. This is upper bound minus lower bound, so 30 minus 24. Then I have 0.5. Those 0.5 are fixed for the median. We always have 0.5 minus relative cumulated frequency of the class before, that one up here. Finally, divided by the relative frequency of the median class, 25.96%. If I insert all these values, this will lead me to an end result of 27.1109. That's our median for the age. Well, this was already the first measure of central tendency we had to calculate. Now in the next slide, we can continue with the mean. For the mean, again, we're using the same frequency table, but we need something else here as well. We need the mean of the groups, so the value in the middle of the groups. So we can simply go 25 plus 18 divided by 2. 30 plus 24 divided by 2. 40 plus 30 divided by 2, giving us the value in the middle of these groups. Once we have these group means, that's the MI here, we're just going to multiply them with the relative frequencies. So group mean, the value in the middle here, which is a result of 18 plus 24 by 2 times this relative frequency. Here, 27 times this relative frequency, 35 times this relative frequency, and so forth, gives us this intermediate result. Always the class means multiplied with the relative frequencies. This, in the end, leads to a result of 33.3596, which is slightly larger than the median, meaning this will tell us something about the distribution of the dataset. So in this case, whenever we have a mean which is slightly larger, which we can also see here, we have more smaller observations and a few larger outliers. This is an indicator of so-called rightward skewed datasets. So we can use the comparison of median and mean to also get an insight into the skewness of the dataset without having to calculate skewness as an indicator, as a measure on our own. Well, that's then it on this exercise. So I hope you enjoyed it. I say goodbye and see you next time.